we'll do a couple things this afternoon. Dave Ryan here is with us, and Dave's been, he'll do a little more of an introduction, but Dave was at NCAT when I first met him, and I talked Dave into going to Poplar to do some wind energy stuff, I think, back a while back, and Dave did a good job with that. So I was glad to see, actually, I thought Dave was still at NCAT. He since went independent, and he knows an awful lot about a variety of different energy things. So today he's going to talk about irrigation. We went and looked at a little bit of the equipment. Of course, they finished irrigating Saturday, first time over, so they had water flowing and anything. So we did buy a flow meter, Extension did. So it's set up actually on the geothermal heat pump in the other room. So we'll go take a look at that. So with that, I'll kind of turn the afternoon over to Dave, and I know he said he'd give us breaks and things as we went. So with that, Dave.
Maybe. Okay, I live in Butte. I'm a mechanical engineer. I worked for the utility, Montana Power Company and Northwestern Energy for 13 years, doing energy conservation and renewable energy programs. I actually honestly developed the renewable energy program for Northwestern Energy, so if anyone doesn't like the Northwestern Energy renewable energy program, they can blame me, okay? But it's actually a very successful program. Did a lot of net metering, okay? No one had ever done net metering in Montana before, and when I left the company, there were 350 net metered systems on Northwestern Energy. Now there's about 1,800, so it's for the size of the utility, probably more net metered customers per utility customer as a whole for any utility in the United States except for Sacramento Municipal Utility District. So pretty successful program, successful enough that the utility would love to get rid of it, but anyway, that's a different story. So then I went to work for NCAT. I was at NCAT for nearly 10 years, and at that point I got laid off. This was back at the end of October. So then I just spent, I had been contracting over the years, ever since I went to work for NCAT, so 10 years, contracted on the side, did a little bit of work for different people, mostly in the large-scale wind development arena. So I did contracting, and so I said, well, okay, I could go back and try to find a real job, or I could try to expand my contracting. So I've been trying to expand the contracting since then, and I told Joel about, boy, feast and famine doesn't say what it's really like, okay? But anyway, in my previous life, I was a coal miner. I was a heavy equipment shop foreman and maintenance planner in surface coal mines. So I exchanged my greasy coveralls to a coat and tie when I went to work for the utility. It was kind of a culture shock. So anyway, I tell people I don't know much about plants, but I do know quite a bit about energy and energy issues, energy conservation. So I did get my certification as a technical service provider with the NRCS, and I'm the only one in the state that's certified to do these CAP 122 headquarters audits, okay? So if you know anybody that wants a headquarters audit, I'd love to do it. I'm not the only person that can do them in the state, because other people that are outside of the state are also certified. But we can do headquarters energy audits, and we can do irrigation audits also. So even though technically the irrigation audit is under the landscape audits, I think that's CAP 124. So I hope that this is interactive. So if somebody has something humorous or even serious to bring up and talk about. You guys probably know, I'm certain that you know more about agriculture than I do. I'm an energy guy, as I say, a mechanical engineer, and I tell people, as far as I know, those plants are those green things, and some of them have stickers, okay? So that's about the level that I'm at. I did just go through level 1 Master Gardener class. Yeah, woo, woo, woo. Yeah, badass. So that's, yeah, so I actually, learned some of these, and some of that stuff actually made it into this presentation. Okay, so I think everybody makes mistakes, and I usually tell people that I'm terrible at math. And people go, well, you can't be terrible at math and be a mechanical engineer. Guess what? I can still be terrible at math. So, so always, whenever you do a calculation, or whenever I do a calculation, I go back and I check those numbers, okay? So when I talk about using computer models, and I use computer calculators, if it's a calculator that's that I haven't used before, if it's a very complicated one, I will find more than one. Okay, I'll try more than one and make sure that I'm getting close to the same answers from the different little software packages, because you can always find more than one calculator for these different things. So always be careful about that. I made quite a bit of effort to make sure that all of the resources that I put in here are in the public domain, or I got permission. So if I've got a picture in here that I don't have permission and someone criticized me for it, I'll just remove it from the presentation, and we can do that.
I just blame it on JP if that ever happens.
Blame it on JP? Oh, okay. It's JP. Yes, this is being filmed. How about this? This is what they call an indie. Yeah.
And I think we're putting the film on the extension server, so it'll be agents only.
Okay, that's a relief.
Yeah.
Okay.
Yeah, they're not like a wolf pack.
They're all kind.
Okay, so we only get mocked by other extension agents, not
Yes.
by the public.
Yes.
Okay.
It's important clarification at times.
Yeah. So if I blow over something on a slide, if I neglect something, you can stop me and get me to talk about it. If this is very interactive, it'll go long. We'll go past 6 o'clock. If you're just going to sit there and watch, then it's going to be less. Okay. Now I know that might sound like motivation to not say anything, but hopefully we'll get some discussion going.
No matter when we end, it will be beer 30.
I
So whether you rush or not, that will be
Yeah,
the end.
if you don't interact, we're just going to sit here for an hour.
Joel brings the beer at 6 o'clock and
Yeah,
we'll
no-
stay here all night.
No problem. The last break, 10 minutes, we can rush into town, get some beers, bring it back. I tried as best I can to put the references to the things I'm talking about at the bottom of the screen. So hopefully when this is online, you can get to those links, and some of them are long, and I'm sorry about that, but I just scraped them off and pasted them into the screen. So anyway, there's a lot of, probably the most value in the presentation is the references on the screens, because that's all the tie-in where I found all this stuff. Okay, so kind of a brief outline. We're talking about safety, a little on economics, environmental issues, irrigation, energy, the costs, and basically, and kind of conceptually, what we're buying when we're paying our energy bills for irrigation, a little bit on the technologies themselves, engines, motors, pumps, and I think there's a slide on NRCS and utility programs. at the end, and we're going to talk about why we're concerned about irrigation efficiency, who cares, all this. A little bit about pipelines and distribution systems, the actual conservation strategies in the different pieces of the irrigation systems, energy audit basics. So when we go out and actually do an energy audit, this is what we actually do when we're doing an energy audit. Calculations, everyone loves those, right? Those are where I make all my mistakes, come out with off by a factor of 10 and stuff, and that's why I don't ever get a bid, because I'm either 10 times too high or 1/10. And some recommendations for farmers. So why are we interested in efficiency? Well, if we improve our efficiency, we can save money. And so I think that farmers are very cost conscious. I mean, more so, I think, than any other kind of demographic that I work with as an energy engineer. You can go to a businessman and you say, well, I'm going to go look at your office building and come up with some measures, and you're going to save some money, and it's going to show some payback. And they're like, oh yeah, that's great, I'll take a look at it. But boy, farmers are just like, they really need to have good economics, and they really want you to show that that whatever you're doing has good economics. And they're very, very cost conscious. And in my experience, the farmers I've worked with, on the whole, are much more cost conscious than other demographics. And copper wire was invented when two farmers got in a fight over a penny. Anyway, there's potential water savings, okay, and the potential water savings is huge, okay, and we'll talk about these different scales of projects, and there's fertilizer savings also, and I didn't really get much into the fertilizer savings, but I wanted to mention that, especially when, and I don't know, I think that some farmers do put the fertilizer right in the irrigation water. I don't know how common that is in Montana. I'm sure that you've seen it.
Pretty rare in Montana.
Yeah, but you'll get them that they put the ammonia right into the water. So anyway, but I just wanted to mention that there's also cost savings for fertilizer, because we can keep it from running off, okay, if we don't over water. So anyway, I've got to talk about safety. When you're working around this machinery, out in the these farmers, I'll tell you what, they can put these things together and they work, but you've got to be very conscious when you're working around them, because you can get caught in them. Okay, and this is a very nice little drawing of a guy getting his arm chopped up, by this drive line, and it's all the more somewhat poignant because this guy is wandering around by this unprotected drive shaft, and he doesn't care about it at all. So there's all kinds of different ways that you can get hurt around this equipment. So if you're out looking at equipment, and this is a very broad brush statement, but whenever you're looking at equipment that's powered with electric power or mechanical power from an engine, there's danger. Okay, so you got to be careful. These are these little caution symbols and the safety industry has undergone a big change with Occupational Safety and Health Act. When was that? About 1978, 79, sometime in there. So always before the danger symbols were all, it's kind of a mishmash of different symbols, and you still will find old safety symbols out there, but these are the new ones. So if you kind of see a yellow triangle on something with, someone's hand getting cut off or something, then it means that you've got some sort of risk there. Okay, so be conscious of those symbols.
I'll have to ask Darren if he can have one for the rotted wood over 12-foot hole.
Yeah, yeah.
We were standing on earlier.
Right. Well, and this is what you can do. And you know, I was thinking about this when we were looking at this turbine pump over here. You know, if you fell down in that hole, for one thing, you would not get out without help. Okay. And you would probably drown. Okay. So you know, you could slip and fall and drown in this thing, you know, and it's like, oh, it's scary.
I
So
made a point to wait till Tom got off that board before I crossed over.
yeah,
We would have had a one at a time limit.
yeah. So and I can't tell you all of the open electrical boxes I see when I am out working on it, doing energy audits, and exposed wires. I went through a poultry farm where there's poultry litter dust everywhere and live wires just, you know, twisted together. So you really have to, you know, watch it when you be careful on these things. Everyone has heard stories about someone moving irrigation pipe and getting it into a power line. Okay, an irrigation pipe, a piece of irrigation pipe is how long? Any guess? 20 feet. Is it 20 feet? I think, yeah, a piece of pipe is usually 20 feet long. And the cross arm on a standard utility distribution pole of 7,200 volts is 22 feet. And so those lines sag, okay? So it's pretty easy. You can get, and they're not insulated. Okay, none of those lines are insulated. So you can provide your 7,200 volt path to ground with your body, okay, and it'll kill you. Entanglement we covered. Operation, this is kind of a fun thing here. You can, when you first start up the irrigation pump, the pump has to get primed, okay, and get water to it. So then once the water is to the pump, then you can open the main line valve and let the water out into the system. Well, you don't want to run the pump with that valve closed very long, because people don't think of this, but the work that you're putting into this fluid inside the pump is going to be enough to make it into steam. Okay, so as you make it steam, the pressure shoots up and the pump can explode. So this is not an irrigation pump that exploded, but there was a really fun YouTube video of an irrigation pump exploding, and I could not. When I looked to do this presentation, I looked pretty hard for that video because it was a lot of fun. Because people were watching this pump. It was a vertical turbine pump like this one over here, and it just exploded, poof, So, and if you're near it, then it's going to be steam, So, all right, enough about safety. Economics. This is one of my fun quotes. It's the economy, stupid. It's Chester James Carville Jr. He was Federal Reserve under not Carter, but Clinton. So anyway.
He was a news guy after that.
Yeah, well, and he was a consultant with the Bush administrations also. Okay, so you can grow wheat 50 bushels an acre, and this is where you guys will laugh at some of my numbers maybe. $7 a bushel, so that's worth $350 an acre in revenue. Here's soybeans, 40 bushels an acre at $15, $600 an acre. So the soybeans are irrigated. The wheat is not irrigated. And so the irrigation costs, the system costs, about $140 an acre, and this is, I think that this is capital and expense costs. So $36 an acre is the water. So you can see that if you have this choice, you can pay for the water in the irrigation system, and you can make more money from an acre if you've got water You can make more money per acre. I mean, that's the point of the slide. So I hope that that's correct. I think it's correct. So that's why we irrigate. So that, economics are good. And farmers and all of us, most of the time we ignore externalities. And what's an externality? Most of these are environmental issues. So now, is everyone an environmentalist, or no one cares? Okay. Who cares about that stuff? Global warming. In-stream flows, okay, you face it, you pump all the water out of the river and put it on the farmland, you're not gonna have a fish, okay? So some people like fish. So if you like fish, you want some water to be left in the river. What's it worth? What's it worth to fish? Well, it's recreational, maybe no one cares about fish. The farmers want to raise their crops. So soil conservation, a big problem with irrigation systems is we run them more than they need to, and then we have runoff, and that causes soil erosion, causes sediment building up in the other streams downstream. Effluent, we call it effluent, usually we think of it from wastewater treatment plants or something like that, but it's really effluent is fertilizer and pesticides, residues getting washed off into the water supply. Tourism is one of those fish things, okay? So you want people to come to Montana and fish and enjoy the rivers, but if the river looks like this, they're not gonna come. Urban water uses, the votes are all in the city and not in the farm, and so this causes tension, between these different groups. So these are environmental externalities, and very rarely can we put a dollar value to them, but it drives me crazy